Hello everyone, my name is Lufia Jodzi, research scholar of Christ Deemed to be University. Here I am presenting my paper entitled by Unbalanced Dataset Preprocessing using Hybrid Algorithm for Arrhythmia Detection. So, abstract. We know that timely prediction of cardiovascular diseases with help of a computer-aided diagnosis system minimizes the mortality. Nowadays, the cardiac arrhythmia detection is one of the most challenging tasks because the variations of electrocardiogram signal are very small, which cannot be detected by human eyes. Arrhythmia is a condition of abnormal rhythm. In this study, a new convolutional neural network model is proposed for classification of the MIT BIH arrhythmia database into 5 classes. Here addresses the challenge of the class imbalance in the analysis of arrhythmia data utilizing the hybrid combination of three approaches like Tomke-Link's ResBoost classifier and Adazin. Here we have used the hybrid combination of these three methods. Additionally, here provides a thorough analysis of new preprocessing model approaches for diagnosing heart diseases. By comparing the performance of these methods, this research contributes to the development of the robust and accurate arrhythmia classification models with potential applications in clinical diagnostics and the healthcare decision support systems. Here I am showing the overall diagram of my project arrhythmia detection. The first stage is image acquisition, then preprocessing stage. That means the hybrid algorithm portion. Then we get the result like balanced data. After that balanced data given to the train and split section. Then build the model. To get the better result, firstly input data goes through the training and testing section. The final stage is the result evaluation. In this stage, we can understand that the input data whether it is affected by arrhythmia or not. As I told earlier, here we are used three methods like Tomke-Link, ResBoost and Adazin. According to Tomke-Link, which is a technique employed to address the class imbalance within the dataset, and it mainly aims to improve the quality of the training data by reducing the overlap between the classes. The algorithm then selectively removes the instance from the majority class in each pair. In this method, the minority feature extraction is the selected feature of our project. And second portion is a ResBoost classifier, that means the random undersampling with boosting, and which is an oversampling techniques designed to address the class imbalance by generating the synthetic test for the minority group. This approach ensures that the synthetic samples are generated, capturing the underlying data distribution more accurately. By balancing the data and emphasizing the importance of the minority class, ResBoost equips the model with the necessary tools to make accurate predictions for arrhythmia detection. In these methods, we know that this is an ensembling algorithm. Here, the selected features are the random undersampling methods, boosting, and iteration methods. According to third model Adazin, that means the adaptive synthetic sampling method, which is a combination of two powerful techniques. The unique strength of Adazin lies in its adaptability to the local distribution of the data. The effectiveness of Adazin may change depending on the specific characteristics of dataset, and careful tuning of the parameters may be necessary to achieve the optimal result. We know that by using the adazine, the minority instances are not degraded, and that is the first selected features, and we can create the synthetic samples, that is second one. That means it eliminates the border data, so the complexity will be reduced. These are the selected features of the adazine method to our project. Here I am explaining my work. This is hybrid algorithm. The input is imbalanced dataset. The desired output will be balanced dataset. The first stage is initialization. Then identify the nearest neighbors, which means for each instances in the dataset we have to calculate the distance to all other instances in the dataset. Here, the dataset distance metric used is typically Euclidean distance, but it can be any distance measure suitable for the data. Then, find out the Tomke links. A Tomke link is defined as a pair of the instances, that means x and xy, which means x belongs to the minority class, y belongs to the majority classes. According to its working, once Tomke links are identified, remove the instances from the minority class that are the part of these links. Actually, the removal process aims to eliminate those minority instances that are in the close proximity to the majority class, as they might be causing the confusion to classifiers. In the third step, calculate the class imbalance ratio. That means a second method like the adazine. Mainly, that will help to calculate the required number of the synthetic samples for each minority instance, which is step 4. In step 5, the neighbor selection. For each minority class instance, identify its k neighbors from both minority and majority classes in the feature space. The number of minority neighbors k is typically a user-defined parameter. In step 6, estimate the density distribution differences, which means calculate the density distribution difference between the minority class instance and its neighbors. Actually, the difference qualifies how similar or dissimilar the instances is to its neighbors. In step 7, calculate the importance of each minority instances, which is based on the density distribution difference. Basically, the instances that are more dissimilar to their neighbors will have the higher importance. Then we have to apply the third method, the random undersampling, that means the RUS booster. Here, randomly undersample the majority class to create the balanced or nearly balanced subset of the dataset. Basically, this step aims to reduce the dominance of the majority class and prevent the classifier from being biased toward it. Then we have to calculate the weighted error of the base classifier on the entire data set. Then weighted error accounts for the fact that the data set is imbalanced, giving more importance to the minority classes. The next step is classifier weight calculation. Here we have to calculate the weight of the base classifier in the ensemble based on its weighted error. Then update the weights of the samples. That means updates the weight of the training instances in the majority classes. In the last stage, repeat until the boosting process is complete. This is the overall working of my hybrid algorithm. Here I am showing the comparison study of my method with another existing methods. And this is the result and discussion with existing work comparison. The bar graph displays the number of the instances or count or samples in each class after applying the existing algorithm. In the first graph, you can see PCA applying result, entirely the data distributed asymmetrically. Like that, the Gaussian naive Bayes, KNN, SVM, LDA, wavelet also shows the asymmetric distribution of the data. And next slide shows the result and discussion of my proposed method. And this result shows the class distribution after using my proposed system. In this figure, you can see it well exhibits the nearly equal slices values, which means it indicating that the data has been effectively balanced across the different classes. So, conclusion. The integration of Tomcat Link's ResBoost and Edasyn techniques has proven to be the instrumental in addressing the challenge of class imbalance within the Arrhythmia dataset. These methods collectively led to the creation of the balanced dataset, thereby substantially enhancing the accuracy and overall performance of our arrhythmia detection models. By strategically emphasizing the characteristics of the minority class, these approaches have paved the way for more robust and reliable classification systems. This progress holds the great promise for the advancement of arrhythmia analysis in clinical settings, potentially revolutionizing the diagnostic process and facilitating timely medical interventions. So this is my proposed method. So thank you so much to give me this wonderful opportunity to present my project topic in WICT 2023 conference. Thank you.